I'm just gonna give you a warning real quick. I'm not gonna lie. I used the cross product to find the angle between three component vectors in another video. Yeah, that's the extremely hard method. You can use dot product as well, okay? I just I wasn't thinking when I made the video. I'm gonna leave it up because it still works, and maybe your homework assignment tells you to do it. But yeah, we're gonna use dot product. So we're gonna dot product to find the angle. Dot product angle 3D vectors. So wait, why does the pencil look like extra thick today? Pause. I don't mean it like that. But let's say we have a vector. Okay, we're going to use the dot product, but let's just give the vectors. Let's give the vectors A, 3, 5, 6, and B, 1, 2, 3, because those are easy numbers to use. Maybe not. I mean, like just easy numbers to guess, because I didn't really prep for this video. I'm not gonna lie. But given these two vectors, we can actually use the formula of the dot product between them. So A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. So we don't actually have the angle between them, but we can solve for the dot product and their magnitudes. So let's solve for the dot product between them. That's why it's easier, because you don't have to do cross product. Okay, but let's go do that. Dot product between A and B is 3. It's actually a scalar value, so it's not in a vector. So 3 times 1 plus 5 times 2 plus 6 times 3. And all this simplified is equal to 3 plus 10, 13. 13 plus 18 is 31. Let me use my calculator because I'm not going to lie, I messed up 1 plus 4 plus 9 in the previous video. So let's just use a calculator just to double check this. Yeah, 31. Okay. So the dot product of A and B is 31. Save that. Let's put a little green box around it. And you could put 31 into here. Let's actually change the color. So it's easy to differentiate. But then we can find the magnitude of vector A. Let's go ahead and do that. Is equal to the square root of 3 squared plus 5 squared plus 6 squared. And this is equal to the square root of 9 plus 25 plus 36 square root of 70. So the magnitude of A is square root of 70. Let's save that. The magnitude of B is equal to the square root of 1 plus 2 plus 3. Okay, let's not mess this up this time. This is the square root of 14. In the previous video, for the cross product one, I did square root of 15. So this one is going to be square root of 14, which is the actual right answer. And let's write in red. Square root of 70, square root of 14. So once that is done, we can actually isolate theta, because theta is the only unknown value. So if we have 31 is equal to square root of 70 times the square root of 14 times the cosine of theta, we can actually isolate theta by dividing 31 by both these values, both the magnitudes. This is equal to the cosine of theta, and we can arc cosine or inverse cosine. Both of these are synonymous when you see them. This doesn't mean cosine to the power of -1. This means inverse cosine. So I'm just going to use arc cosine as the symbol that we're going to use for inverse cosine. Just arc cosine 31 over the square root of 70 over the square root of 14. This is equal to theta. So if you plug this into the calculator, you get arc cosine, let's do 31 divided by square root of 70, square root of 14, arc cosine answer, and then you get 8. Literally 8 exactly, almost. So the theta, or the angle between these two vectors, is literally 8.004 degrees. Okay, let's move on to the next problem. Make sure not to erase the formula. And then let's use, I don't know, some different values, like 3, -4, -6 or something. And then 5, 6, negative 9. Okay, let's find the dot product of A and B. So A dot B is equal to 3 times 5 plus, well, this is going to be negative 4 times 6 plus negative 6 times 9. I'm just going to cancel the negatives because it'll turn positive anyways. Is equal to 15 minus 24 plus 54. And let's use the calc. 15 minus 24 plus 54 is equal to 45. So we have 45. Let's square this. Let's put a square around it, and let's put 45 down here. Okay, now once we have that, let's get the magnitudes of A and B. I don't think we'll have enough space down here, so I'll just start over here. The magnitude of A, I honestly want to do this in order because it's easier for you guys to see. So let's do it down here. Yeah. Change my mind. 3 squared plus 4 squared plus 6 squared. And B is equal to 5 squared plus 36 squared plus 81 squared. Ooh. Oh, fuck. I already squared everything. Hold up. I was doing the math like already. Hold up. This is 6 squared then. Let's write that. 6 squared plus 9 squared. Okay, so the magnitude of vector A is 9 plus 16 plus 36. And 25 plus 36 plus 81. Okay. So the square root of 61 and the square root of 142 are the magnitudes of vector A and vector B. And then once we get that, we can plug in the values. So 61 and square root of 142. And then let's go ahead and write the whole thing down, separate it. 45 is equal to the square root of 61 times the square root of 142 times the cosine of theta. You get 45 divided by square root of 61 times 142 is equal to cosine theta, because we divided the square roots onto both sides. And then now all we have to do is arc cosine both sides. So arc cosine 45 divided by square root of 61 times the square root of 142 is equal to theta. And then let's go ahead and solve for theta. Calculator. Yeah, don't try to do this like in your head. I don't know. My old teacher for geometry told me that for some reason they memorized the charts for all the arc cosine values, which is kind of crazy. But what we get out of this is 61.08, 0.09 rounded degrees. Okay, let's just do one more problem, because honestly, this is literally just solving for dot. Just all you really need is this dot product formula. Quite literally, after that, it's somewhat self-explanatory. I mean, if you just look at all the values here, if you're given the 3 components of the vectors, all you need to solve for is the dot product and their magnitudes. And hopefully by now, you know how to do that. And once you do that, it's just algebra from there. Isolating theta. And a little bit of trig because you have to use arc cosine. But, let's not get literal on me. Okay, negative 10, 5, and 6. 3, negative 4, 1. Because I'm lazy and I don't want to do more math. Is equal to negative 10 times 3 plus 5 times negative 4 plus 6 times 1. See, now I really don't know what I'm doing because I have a chemistry exam tomorrow and I'm making YouTube videos because I want to procrastinate studying. Thanks for giving me the opportunity, guys. Plus 60. Okay, let's just write down 44. All right, negative 44. Yes, hopefully I'm right. Okay, let's put a square around this and then write down negative 44 for the dot product here. So the magnitude of vector A is equal to the square root of 10 squared plus 5 squared plus 6 squared. The magnitude of vector B is equal to 3 squared plus 4 squared plus 1 squared. And if you don't know how to find the magnitudes yet, I'm just going to reiterate it. Maybe some of you don't know. But these are just all three of the components inside of a squared. And then you square root at the end. This is equal to the square root of 10, 25, 36. I'm just lazy, I'm not going to lie. Okay, 161. 161. 9 plus 16 plus 1 is 26. So we have the everything here. And all we have to do is plug these in. So square root of 161, and this is the square root of 26. What we gotta do, rewrite the formula. Negative 44, not 144, is equal to the square root of 161 times square root of 26 cosine of theta. Isolate everything. Negative 144, 161 times 126 is equal to cosine of theta. We arc cosine everything. And we get theta. And then theta at the end, after all this math, is... bro, my hand hurts from writing. Cosine. Okay, 132.85 degrees. And, just to let you know, a quick check, right? Remember, when the dot product is negative, the angle between the two vectors is obtuse. And the reason why is because dot product measures how close, how parallel two vectors are. Just how much in line are they going in the same direction. It's just a number that you can use to see how much they're going in the same direction. If they're negative, then they're going in the complete opposite directions. And I have a video on that actually if you want to watch it. But when the dot product's negative, like here, right, the angle should be obtuse. And look what we got. We got an angle that is above 90 degrees. So if you have any questions, put it down in the comment section. If you're ever solving a problem, use the dot product form to solve the angle between three-dimensional vectors. Do not use the cross product one because that one's like hard unless the question specifically tells you to. So hope you learned something, guys.